So in the last class we've talked about binary to decimal conversion. So next we'll talk about floating point numbers. That is, if there is a fraction, by fraction I mean, suppose it is 101.1. Okay, so this is the fraction part and this is the whole number part. So we've talked about how to deal with the whole number part. That is, here we'll write it as 2 raised to 0, 2 raised to 1, 2 raised to 2, and then we'll calculate the value. So how do you deal with this part? So if this is 2 raised to 0, then the weight of this point, the number just to the right of the point will be 2 raised to minus 1. So don't get this wrong. Since this is 2 raised to 0, this should be 2 raised to minus 1. Okay, so if there are any more bits here, then the values, the weights will be 2 raised to minus 2, 2 raised to minus 3, etc. And here it will be 2 raised to 3, 2 raised to 4, etc. Okay, so 101 we have already calculated, it is 4 plus 1, 5. Point, we have to find what is the value of this 0.1. So in order to find the value of this 0.1, what do we do is, same thing, we'll find it out as 1 into 2 raised to minus 1. This 1 into 2 raised to minus 1. So we know that 2 raised to minus 1 is 1 by 2. 1 by 2 is 0.5. So the value of 0.1 to the base 2 is 0.5 to the base 10. So this will be 0.5. So this will be 5.5 to the base 10, where this is to the base 2. So if we are to take another example, let's take 100.01. Okay, so 100.01, say, to the base 2. So this we have to convert to decimal. So 100, again we know that 100 is, to avoid confusion, we'll write it here. So 100.01 to the base 2. So it is, here it is 2 raised to 0, 2 raised to 1, 2 raised to 2. So here it will be 2 raised to minus 1 and 2 raised to minus 2. So the answer will be 2 raised to 2, that is 4 point something. And what is that? How will you find that? That is 2 raised to 2 into 1 plus, these are all zeros, 1 into 2 raised to minus 2. So that will be 4 plus 1 by 2 raised to minus 2 is 1 by 4. 1 by 4 is 0.25. So 4 plus 0.25 will be 4.25 to the base 10. Okay. So any number of fraction part we can compute by simply assigning the weight. Okay. So now we've talked about how to convert a binary number to decimal. Next we'll find out how to convert a decimal number to binary. So for binary to decimal or any number system to decimal, what did we do? Each bit, each digit of that particular number system multiplied by its base raised to the power of, that is multiplied by its weight. Okay, so the reverse, that is decimal to binary. Suppose we'll take a small number, say 10 to the base 10. Okay, it is 10, not 10. So 10 to the base 10, or we have to convert it to binary. So there we multiplied and added, here we will divide. So 10 we will divide with whatever base we want to convert to. Here we are converting decimal to binary. So in order to convert decimal to binary, we will divide this decimal number continuously with the binary base. So binary base is 2. So 10 divided by 2 is 5. Quotient is 5 and remainder is 0. So here we will write the quotient and here we will write the reminders. Again 5 is again divided by 2, it is divisible, so you can again divide. So you will again divide it by 2. So the quotient is 2, that is 2 2s are 4. 5 minus 4 is 1, that is simple division. So the remainder is 1. So we will continue this until and unless the bit here or the digit here belongs to this particular base. That is 2 is not a number of binary. 2 does not belong to binary. So again we have to divide by 2. We will continue this until everything here is a number which belongs to that particular number system, in this case binary. So 2 divided by 2 is 1, quotient, and remainder is 0. Now after this, what we will do is we will write from here to up. Okay, don't forget the direction we will be writing. In this case it is 1 0 1 0. So the answer will be 1 0 1 0 to the base 2. So 10 in decimal is equal to 1010 to the base 2. So we can check here, the weight is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So this is 8 plus 2 raised to 1, that is 2, that is 10. So hence proved. Okay, you can just check if it's correct or not. That's not necessary, just In the case of conversion, you just need to follow this method and write down the answer. Don't forget to put the base, because that carries marks. Okay, so that is decimal to binary, one number. Now we'll consider another number. Suppose we are taking suppose let's take say 17. 17 to the base 10 is equal to what in binary? So what will we do? 17 is continuously divided by 2, because we want to convert it to binary. So what is the quotient? 8 2s are 16, remainder 1. Again 8 is divisible, 8 is not a number of binary, so again you will divide. 8 divided by 2 is 4 is quotient, it is fully divisible, so remainder is 0. Again 2 2s are 4 and the remainder is 0. Again divide by 2 1s are 2 and the remainder is 0. Now don't forget to put this particular 0. Sometimes what happens is, last one we'll write it as 2 1s are 2 and forget this particular 0, and we'll write it as 1001, which is wrong. So here the answer is, again I told you to take it from down to up, so that will be 1 0 0 0, 3 zeros and a 1 to the base 2. So in order to check, so if we need to check, this is 2 raised to 0, this is 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. So 2 raised to 4 plus 2 raised to 0. So 2 raised to 4 is 16 and 2 raised to 0 is 1. So 16 plus 1, it is 17. So hence checked. So this is your answer, and we have proved that the answer is correct. So when we talk about this decimal to any number system or any number system to decimal, the rules are the same, only the base will differ. Okay, so if you know how to convert a binary to decimal and decimal to binary, then the rule remains the same for any other number system. Octal to decimal, decimal to octal, hex to octal, hex to decimal, and decimal to hex. Okay, only condition is that the one of the number system should be decimal. Okay, so when we talk about this, we should also know about the fraction part, that is say it is 15 point say 5, let's take it as 25 to the base 10 is what in binary. So 15, in order to do this, we have to do it in two different ways. 15 you know how to do, divide continuously with 2 until and unless you reach a point where all the quotients are the final quotient is a number which belongs, a number or digit which belongs to that particular system. Okay, so 15 we can very easily write. 15 is 2 7, remainder 1, 2 3, remainder 1, 2 1 1. And as per the rule, you have to write it like this. So the answer is 1111 point. Then you have to find out this particular value, 0.25. So coming to the fraction part, 0.25, here what we will do is, we will multiply it with the base. Here we divided, here we multiplied. This part we will be dividing with the base, this part we will be multiplying with the base. So what is 5 into 2 is 10, 2 into 2 is 4 plus 1, 5, 0. Now what we will do is, this 0 we will write it here. Okay. So if this was a 1, we will write it again as 1 and multiply again with a 0 only. We will remove whatever is here to this point. This will be either 0 or 1 only. Okay. So if this is 1, we will remove it to here and multiply only the fraction part, because we have already removed the 1. Here in this case it is 0 itself, so nothing to remove. So again we will multiply with 2, 0, 5 into 2, 10. So this 1 will come here. So what happens? We will remove this 1 and bring it here. Okay. Now the difference is, here we took it from bottom to top. Here we will take it from top to bottom and write it as 0.01 to the base 2. 0.1 means 0, 1, 0, 1. Okay. So this is the conversion of decimal to binary, both the fraction part as well as the whole number part. So next we'll talk about octal to decimal conversion. So we know what is binary to decimal conversion. Likewise, octal to decimal conversion. So if we have a decimal number, an octal number, say 245, that is a number in octal. This we have to convert to decimal. So binary to decimal conversion was, write down the weight, multiply each digit with the weight and add all the products together. So here same thing, only the base will change. So here it will be 8 raised to 0, 8 raised to 1 and 8 raised to 2. So we will write it as 2 into 8 raised to 2 plus 4 into 8 raised to 1 plus 5 into 8 raised to 0. So that will be 64 into 2, that will be 128 plus 8 4s are 32 plus 5 into 1, 5. So that will be 165. Correct? Yes, 165 to the base 10. Okay, so only difference with binary to decimal conversion and octal to decimal conversion is that there we used 2 instead of 8. Here we are using the base 8. Likewise, in the case of hexadecimal, we will be writing the weights as 16 raised to 0, 16 raised to 1, 16 raised to 2, etc. So, together with this, if we had, say, if the question was, say, 245 point, say 5 to the base 8. If this was the question, how will we find this 0.5? 0.5, we will do it as, that is 8 raised to minus 1. This has a weight of 8 raised to minus 1. 245 we have already found as 165. So, 165, that is 2 into 8 raised to 2 plus 4 into 8 raised to 1 plus 5 into 8 raised to 0 plus 5 into 8 raised to minus 1. So, that will be 1 by 8. So, 5 by 8. This fraction part will be 5 by 8. So, that much to the base 10. Okay. Likewise, in the case of hexadecimal, it will be 16 raised to minus 1. 16 raised to minus 2, 16 raised to minus 3, etc. Okay. So, the basic principle of all the conversions from decimal to a number system and a number system to decimal, both are the same, only the base will change. So, if we are going to consider a case where we need to convert decimal to octal or any other number system, decimal to octal. Decimal to octal will be, say, suppose it is 18 in decimal is converted to what in octal. So, that will be 18 continuously divide by the base 8. So, 8 2s are 16, 1. So, what happens here is 2 is a number which belongs to octal. So, we needn't divide it again with 8. In this case, 2 is a number which is an octal number. So, this is the answer, and how do you write the answer? From here to here. So, the answer will be 21 to the base 8. Okay, you can check if it's correct or not. So, this will be 2 into 8 raised to 1 plus 1 into 8 raised to 0. So, that will be 2 into 8 plus 1 into 1, that is 16 plus 1. Sorry, here it is 2. So, here it is 2, here it is 2. Okay. 8 2s are 16 and remainder is 2. So, this is 18 to the base 10. So, the answer is 22. Correct? So, this is hence checked. Likewise, if we need, suppose, a fraction part also, Suppose the question was something like 18 point say 5 to the base 10. In order to convert this, 18 we already know it is 22. 0.5 we will multiply by the base. So this will be 0 and here it will be 4. So like I already said, whatever comes to this part to the left of the decimal point to the point, that you will remove and we will multiply if there is a number here with 8 again. Okay, so here we just have 4, so we don't need anything more. So that will be 22.4 to the base 8. So we can check it. 22 we have already checked. 4 is 4 has a weight of 8 raised to minus 1. So 22 plus 4 into 8 raised to minus 1. So that is 22 plus 4 by 8. So that is 4 by 8 is 1 by 2. 1 by 2 is 0.5. So 22 plus, what did I do? Sorry. Okay, 22 it is, okay, 22.4. We are going to check whether it is 18.5. So this is 8 raised to minus 1, this is 8 raised to 0 and this is 8 raised to 1. So that will be 2 into 8 raised to 1 plus 2 into 8 raised to 0 plus 4 into 8 raised to minus 1. So that is 2 8s are 16 plus 2 into 1 is 2 plus 4 by 8, 4 by 8 that is 1 by 2 that is 0.5, that is 18.5, hence checked. Okay, so that is decimal to octal conversion and we did the octal to decimal conversion also. Likewise, you can do the hex to decimal and decimal to hex conversions. So next is hexadecimal to decimal conversion. So we know that in hexadecimal we have numbers from 0 to 9 and then from A to F. So in order to convert hexadecimal to decimal, suppose let's take a question 85C to the base 16. So this we will take it as, in 85C, C has 16 raised to 0, this is 16 raised to 1 and this is 16 raised to 2. So that will be 8 into 16 raised to 2 plus 5 into 16 raised to 1 plus C. C is 12. 12 into 16 raised to 0. So 16, 8 into 16 square plus 5 into 16 plus 12 into 1. So if you calculate that, can you tell me what's the answer? So you will get it as 2140. So this is the case of a non-fraction question. Now suppose it is 85C 0.5. So this is to the base 10. So here we have an extra 0.5. So we will have to find that of 0.5 also. So 0.5 will have a value of 16 raised to minus 1. So the answer will be 2140 plus 5 into 16 raised to minus 1. That is this total plus 5 into 16 raised to minus 1. So that will be 2140.625. 5 by 16 raised to 5 by 16 is 0.625. So this much to the base 10. Okay. So that is the conversion from hex to decimal. Next, we will find the conversion from decimal to hex. So decimal to hex. So in order to convert decimal to hex, suppose we are taking 17 to the base 10. So 17 you need to convert to hex. So 17 divided by 16, 1 times 1. Okay. So in this case both are ones, but anyway we have to take from down to up. So that will be 11 to the base 16. So 11 to the base 16. So in this case I told that A is 10, B is 11. This 11 and B is different. This is 11 to the base 16. 11 to the base 10 is B to the base 16. Both are different. So when do you write 11 as B? If 11 comes here or 11 comes here as the quotient or as the remainder, then you can write it as B. In this particular case, 1 is the quotient and 1 is the remainder. So you will just write it as 11. Okay. So in another example, say we are taking it as 165 to the base 10. So then 165 divided by 16, that will be 10 times and remainder is 5. So in this particular case, here we have 10 as the quotient. So this you will write as A and then 5. So the answer will be A 5 to the base 16. Okay. Now suppose we have 165 point say 2 to the base 10. So for that 165 we already know 0.2. 0.2 how do you take? 0.2 into 16. So that will be 32. So that will be 3.2. Okay, 0.2 into 16 will be 3.2 and we will take this 3 out and 2 will again get multiplied by 16. Again you will get 3.2. Again we'll remove the 3. So in this case 3 will be removed. So what is remaining is 0.2. And 0.2 is multiplied by 16 again. That's why we again get 3.2. So this, in this particular example, this will continue infinitely and you will be getting 3. Okay. So you will write it as A5.33 to the base 16. Okay, so that is conversion from decimal to hex, and we also learnt about conversion from hex to decimal with both floating point and whole number. So you can take up different questions and find out the answers to different conversions.